can be mapped into the set of first order differential equation and can be solved in terms of eigenvalue, eigenvector decomposition. So I think we can practice some of the problems on that and have discussed some of the problems with that. We can also pick up many problems for you. So you should go back to your class, your textbook, and the textbook you can calculus book. We can see the whole lot of problems and we can just try to solve them definitely. And with that, you have much more broader perspective. In fact, things will be very much interesting if you get the complex eigenvalue. What will happen if you get complex eigenvalue? Have you ever tried out? You see, situations may occur. You may have repeated eigenvalue. I will say that is out of the syllabus, outside the syllabus for the first place. Definitely I am going to do it. It's not, I am not going to leave that. So, dx equals to x, what we discussed last class is for the distinct eigenvalues. For distinct eigenvalues and you got the eigenvectors. Now, eigenvalues can be complex also. Okay? If the eigenvalues are complex, then what actually the solution? You saw e to the power minus t minus 2t. What will happen if eigenvalues are complex? Yeah, so it will be like e to the power I theta, e to the power I x something. So if you saw e to the power minus x, e to the power minus 2x. So if it is complex quantity, and always complex quantity will appear as conjugate. If I is one solution, complex conjugate is minus I, and this will act as a pair. You have seen in class 2 calculus, so please review the class 2 calculus book. You know, in that case you can really appreciate what we are doing in this course. So we will have e to the power say ix and e to the power minus ix. So if you see that e to the power ix minus ix is coming and dy was theorem is there, e to the power I theta equals to cos theta plus I sin theta. We have done in complex again in class 2 complex variable, right? Similarly to minus I theta. So with that, with the solutions will be coming cos theta and sin theta. This kind of things and just being discussed in class 2 calculus. So this type of problems you can actually look into and see. In the case if you can have a complex distinct eigenvalue, you are getting in terms of cos and sin. Will you be getting from the eigenvalue eigenvector decomposition? That would be interesting. Maybe that kind of problem I may not give in the quiz. In the quiz, problem will be very simple. What we have discussed in the last class, and we have done already. So next we'll be talking about, so we have seen also this type of problem in your book, d2y by dx square plus 3dy dx plus 2y equals to 0. I am putting x square plus x. This type of problem we have done, we have seen. And how to solve this type of problem? How to solve? What is the solution for this type of problem? We have done it. Yeah, one hand please. Yes, complementary function plus particularity. So what is the solution you got? These are basically called as what? Complementary function. And we will get the solution of this in terms of particularity. The solution is complementary function plus particularity, complementary function plus particularity. That's the solution. So how to get particularity solution, that you know. If you are not remembering, please go to Grewal's book. B.S. Grewal's book was actually prescribed in your weekend first and second mathematics. Those books you can find out this type of solution. My question is, the same kind of boundary condition I have given, okay, can you solve by eigenvalue, eigenvector decomposition this problem also? Right? So, question is, this is 100 or 0. Okay, now it is non-zero. So, what I am going to discuss now, dx dt equals ax plus bt. Okay, x vector is here y, and this t and x are same. And this bt vector will be coming like this. So, if I ask you to convert this in this fashion, What will be your answer? Now should be giving a quick answer. What will be your answer for this problem? So it is, what will happen? dy dx, and then what will our other variable? dz dx equals to ax plus bt. That means x is y and z, and we have the other vector. So can you fill up here? Fill in the blanks. 0, 1, minus 2, minus 3, and then right hand side. Right hand side, first entry will be what? Remember that we assumed dy dx equals to z, and it became dz dx plus 3z plus 2y plus this will be acting as time, actually the linear variable. What will be the entries here? What will be your first differential equation? dy dx equals to z. Second differential equation, dz dx equals to minus 3z minus 2y minus x square plus x, and this will act as your bt time term. So this is nothing but x square plus x. Am I correct? Yes?
Minus will be
Plus x square plus x. What is that?
plus
Is that correct? Yes, yes. It is correct. So, the question is how to solve this type of problem. So, here we have extracted, we have a vector b. Yeah, earlier this was not there. So, again, this can be solved by eigenvalue, eigenvector, decomposition, eigenvalue, eigenvector decomposition. Okay, this can be solved by eigenvector decomposition. Let's look at the problem how to solve at the same initial condition. Initial condition will be at x bar t equals to 0, which is x0 bar. This x0 bar, that's the initial condition. So now let's look at how we can solve. So x bar, as I said, a function of time, which is summation I equals to 1 to n alpha I t u I bar, which is the eigenvector. Okay, it's the eigenvector. B bar t is a vector. Okay, and you know that any vector can be expressed as a linear combination of these expressions. So we can also express this as summation I equals to 1 to n beta I t u I bar. Right? We can express this as beta I t u I bar. Okay? So then what is the next step? So we have dx dt equals ax bar plus bt. We write as ddt summation I equals to 1 to n alpha I t u I bar equals to a summation I equals to 1 to n alpha I t u I bar plus summation beta equals to, sorry, I equals to 1 to n beta I t u I bar. Right? So we change the sign and you can see here it is summation I equals to 1 to n, write everything in terms of summation notation, ddt alpha I t, then a and ui, if you put it is lambda I ui, we have seen it. So which is minus lambda I ui, and we have here beta I t and ui equals to 0. Remember that 0 means 0 vector. I am not writing out the 0 vector. 0 means 0 vector. Which is lambda alpha. Yes, you are right. I got a mistake. Sorry. Okay? And as I said, this you can write always in terms of summation I equals to 1 to n gamma I I bar equals to 0. Right? And we know that u I bar are forming the basis. They could be really independent or they could be orthogonal based on the matrix. The matrix is symmetric matrix or matrix is non-symmetric matrix. Whatever. Okay? So, in that case, all gamma has to be 0 because they form the basis. So, in that case, what actually happens? We have ddt of alpha it minus lambda I alpha it minus beta it equals to 0. This is the equation. It looks like similar to dy dx plus py equals to q. You have seen it? How to solve this kind of equation? The p is the function of x, q is the function of x. We have done it integrating factor. What is this integrating factor? It is for integral p dx. Right? How will you do it? Let me revise this. If from here you can find integrating factor. An integrating factor, we have to multiply each term. Right? So what we get? E to the power integral p dx dy dx plus p integral p dx y plus q e to the power integral p dx. Am I correct? So if I assume p is constant, for example, you can have p to px also. In that case, we square by 2. So if you assume p constant, so can we write this two term d dx as y e to the power x? These two terms, and you should go back to the previous one. It will be y d dx of px e to the power px, which is nothing but p e to the power px. Yes. So if y you put constant, we have p to the power px. If y is taken as variable dy dx, e to the power px as intent. So I am getting that. So this is the inherent philosophical perspective of the integrating factor. Okay? So both the terms actually coming out, and which is equals to q e to the power px, and how to do it? Differential of y e to the power px, which is q e to the power px integral dx. And then if you take the integral, what will happen? You will have y e to the power px. It will be integration of this plus integration constant. Integration constants can be evaluated from the condition. This is the way this differential equation, again, this has been discussed in detail in Grewal's book. Please look at B.S. Grewal's book. This entire procedure has been discussed. Okay. So now, coming back to our problem here. How to solve this problem? So now we know the concept of integrating factor. So how to proceed? How to proceed? What is the alpha it? Alpha it cannot be 1. Okay. Alpha it is what? Alpha it is equals to y. So you have this integral, right? So integrating factor is how much here? So what we do then? E to the power minus lambda I. I put here tau. Okay? I put here tau. Tau is a dummy value. Tau is a dummy value. Okay? So what will actually happen? You start deriving from here. Remember that when p is here lambda is constant. Lambda cannot be variable. There's some numbers. We don't need to numerical fit. 1, 2, 3, 3.5, whatever. These are eigenvalues. So if you do that, what will you actually get from here? because I am purposefully putting tau, because if you take integral limit 0 to t, this should be d tau, it should not be dt. I am putting an integration between 0 to t. Okay, I put integration 0 to t. If I put, for example, if I say integral y dx 0 to x, it is wrong. I should have dx prime or some other variable. Even this and this cannot be same, right? We have seen integration. So because this technique, if you want to solve it, you can do. I will solve it for you. Then I am putting limit for x1. So it is y e to the power dx equals to integral 0 to x1 e to the power dx dx. It is x and y e to the power dx 0. The two limits will be there. Y e to the power dx x and y e to the power x or x1. Sorry, x1. Y e to the power dx x1 and dx 0. So this is the multiplication constant. This is that we have done actually. So now tell me what you are going to get here. What you are going to get here. What is the final answer in terms of t and tau? And remember that at the initial condition, alpha I0 is already obtained. Alpha is how to obtain? We have done in last class. How to obtain alpha I0? What is alpha I0 for its symmetric matrix? Any idea? Alpha I0 is symmetric matrix. Inner product x0 I divided by inner product uy dy. Non-symmetric matrix. It is x0 bi bar divided by inner product uy dy. That's it. So alpha is also obtained. Now we get the answer. Alpha it. What is alpha it function? Once you have done it, then you can solve the problem. What is alpha it? What is alpha? Remember that t is constant here, this is lambda. T is constant here. If you don't know, I can derive it again. ddt alpha I t minus lambda I alpha I t equals to beta I t. Integrating factor is e to the power minus lambda I t or tau. Okay. So what will happen? We will have e to the power minus lambda I t ddt of alpha I t. We can put this on minus e to the power minus lambda I t lambda I alpha I t beta I t e to the power minus lambda I t. Next. Am I correct so far? Everything is correct. Next is ddt of what? Alpha I t e to the power minus lambda I t, which is beta I t e to the power minus lambda I t. Okay. Next step. Alpha differential of alpha I t e to the power minus lambda I t beta I t e to the power minus lambda I t dt. Integral 0 to tau. I am putting it. Better. I am putting 0 to tau. Because you want to fix it t, fine. You want to fix it with t, no problem. What actually happened? Integral dx 0 to tau is integral dx is x, right? So it is tau is tau minus 0. Similarly, it will be alpha I t e to the power minus lambda I t tau minus alpha I 0 e to the power minus lambda I into 0, which is 1. So we have only minus alpha I 0 here. Am I correct? Equals 0 to tau beta I t e to the power minus lambda I t dt. Okay. So you have what? Alpha I t equals to alpha I 0 e to the power lambda I tau. Am I correct? Yes or no? it should be alpha I tau, right? Because everything I'm putting tau. Okay, and then plus 0 to tau beta I t e to the power minus lambda I t e to the power lambda I tau dt. Am I correct? Yes or no? This much I am telling you, nobody will tell you. I thought we were going to derive from here. I am just doing blindly by following this one. Any question here? Any doubts? I am just doing simple calculus here. Nothing extra I am doing. Okay? I will show you why I am putting dummy variable here. But so far I am doing simple. If you close your eyes, this is the way you can do. Nothing else is there because this is very common in your syllabus book. Okay, what you got now? Alpha I tau equals to alpha I 0 e to the power lambda I tau 0 to tau beta I t e to the power lambda I tau minus t d tau. Am I correct? Okay. Sometimes what actually happens, since tau is constant the time, what people do, they will write this and they take it outside. Am I correct? Yes or no? Now, this tau I am saying some particular time. So, I can interchange tau and t. What will you get? You tell me if I interchange tau and t, this symbol. I can interchange tau and t. Okay? What is that? What I will get? Final expression? Alpha I t, alpha I 0. Yes, proceed, you are doing correctly. E to the power lambda I t plus into lambda I t. Yes, 0 to t, yes. Beta I tau lambda I, then this dt was that, it will be d tau. Slight mistake was there. That's why I wanted to say. This tau, so now we can see that this t is actually particular time. If I would have said tau, it would have been really confused. I wanted in terms of t or giving in terms of tau. Because tau and t, both are variables, right? When I put the limit here, this tau is any time. This t is also any time. Okay? This t will be any time, tau also any time. They can swap. For example, if I say evaluate 0 to x squared dx, it doesn't make sense. What we do, we put some dummy variable called x prime squared dx prime. Then evaluate x prime cube by 3, 0 to x. So you say x cube by 3 minus 0. This is the way we have done the calculus. Same thing I have done. Okay? It's not very fundamental level of calculus. If you want to learn much on that, you have to go back to get plus to calculus. Okay? There everything is there. Is that clear to all of you? How these things are done? Any question? Vasudha? Anybody? Everything is clear? Okay. So with this, is it possible to solve the previous problem? The previous problem is I have given dy by dx squared plus pt by dx plus 2y equals to x squared plus x. Write out at home. Maybe one day I can take it from you. Are you going home this weekend? Okay. So who will be staying back? Nobody? Yeah. You can stay back and then you can give it to me on Monday by solution. Okay? I think most of you guys will be going. That's the problem. You go back home, they go home and come back. You see a lot of things happening, and next week is a quiz. If you do that, it is your risk, not my risk. Is everything clear here? So you can. So now I am saying that you can solve this dy by dx squared plus dt by dx plus 2y equals to x squared plus x by this technique, and see you are getting the correct result. You know the result, but you can benchmark. So this way you can do it. Now we go to the assignment problem. Problem set 4. I want to solve all the problems in the problem set 4. The reversible reaction, x1 is going to x2, k1, k2 are the reaction rate constants. Or isothermal in the aspect. The forward and reverse reactions are both fast product with rate constants 1, second inverse and 2 second inverse respectively. The initial concentrations of X1, X2 are 2 gram mole per cc and 3 gram mole per cc respectively determine the equilibrium concentrations in the reactor. Okay, so we have seen. So now we will see the application of dxdt in all versatile chemical engineering problems. So first application in the equilibrium chemical reaction. First application in equilibrium chemical reaction. Okay. So your first problem set. Problem number 1. We have x1 to x2, a1 to a2 in a batch reactor. Okay, it's going on simultaneously. So this batch reactor, what will be your kinetics? How to write the equations? Not DNA. You have x1 and x2. dx1 by x2 d equals to
minus k1x plus
k1 x1
plus k2
dx2 dt
k1x1
dx2 dt k1 x1
minus k2x.
in the numbers. What are the numbers? k1 k2 are given, no? 1 second inverse and 2 second inverse respectively.
Minus x1 plus 2x.
Minus x1 plus 2x2 and this one is
x1 minus
x1 minus 2x2. Right, very good. So now the thing is that this is the rate problem, and if one says that equilibrium is achieved, that means if at equilibrium, at chemical kinetics, at equilibrium, one can say dx1 dt equal to 0 and dx2 dt equals to 0. What we are going to solve? x1 minus 2x2 equals to 0. Both are same equation, only one equation. Okay? And at this point, x1 equals to x1e and x2 equals to x2e. Okay? So now we can see that, you can see equilibrium concentration, the ratio is 1:2. Okay? So it is x1e minus 2x2e equals to 0 and x1 equals to x2e. How much is equilibrium concentration? We don't know. Because this is a typical example of non-space solution, right? If you look at, you got this equation from this, minus x1e plus 2x2e, another equation is given x1e minus 2x2e equals to 0. So essentially, you are getting a system of ax equals to 0, where we have minus 1, 2, 0, 0, x1e, x2e, 0, 0. And what is the non-space solution here? x1e, x2e. Non-space solution is the dimension of non-space is 1. So, what is that? 2, 1. So you can see the solution we got, equilibrium concentration, which is not a unique solution. Of course, it will not be. We have seen that if ax equals to 0, if the determinant of a is 0, x is non-trivial, but x is non-unique because x belongs to null space and basis of null space is not unique. Of course, dimension of null space is finite. Number of bases is also finite, but basis of null space is not finite. Okay, could be any kind of basis because depending on alpha could be 1, 2, 3, or anything. So based on that, these things can happen. Now we'll see that this type of problem you get, but this is a typical chemical engineering problem. Now we can tell that okay, so this kind of problem will not be a unique solution. Where will we go? Because we are chemical engineers. So as a chemical engineer, we need to have the unique solution, and we'll show here. If we instead of solving directly ax equals to 0, with ax equals to 0, how you got? You got based on the equilibrium approximation. Where dx1 dt equal to 0, dx2 equal to 0, and you got the equilibrium concentration which is x1 equals to x1e and x2 equals to x2e. Right? So now the same problem will solve with a time dependent approach. And what will happen? Equilibrium can be achieved if time tending to infinity. If time tending to infinity, what will be getting the solution? And I will demonstrate you here. At time tending to infinity, you will get the unique solution, and that is the beauty of this stuff. So one thing we have learned here, when we have equilibrium problem, instead of solving directly equilibrium problem, you solve the time-dependent approach. You solve the time-dependent approach, and we demonstrate here with the time-dependent approach, one can get the unique solution for the batch reactor problem. Let's look at the time-dependent approach for this problem. So we have to now go for dx dt equals to ax. Okay. What is your A matrix? We have seen minus 1, 2, 1, minus 2. Okay. Eigenvalues. Next is eigenvalues. We see that this matrix is not symmetric. It's a non-symmetric matrix. And let's see whether eigenvalues are distinct or not. Of course, these problems we will see. The initial problem, these problems I can tell you that these are all having distinct eigenvalues. You will see the distinct eigenvalue. How much you are getting? How much you are getting distinct? How much you are getting the eigenvalues? Minus 1. Minus 1 you are getting? 0. Yes. 0 minus 3. This 0 is very interesting. I will tell you why this 0 is very interesting. And for this type of problem, at least one eigenvalue will be getting 0. I will show you why. Let's wait for some time. Now, it is quite obvious that for this type of problem, what will be your solution? X bar equals to summation I equals to 1 to n alpha I 0 e to the power lambda I t u I bar. You have seen it. And what is n? N equals to 2. So we get alpha 1 0 e to the power lambda 1 t u 1 bar alpha 2 0 e to the power lambda 2 t u 2 bar. What is u 1 bar and what is u 2? Eigenvalues. u1 bar. What is u1 bar? After that we will go for the transpose because alpha 1 to alpha 2 is not straightforward. Matrix is not symmetric. Matrix is not symmetric. Matrix is not symmetric. U1 bar. Any answer can I get from it? For U1 you are getting 2 1 and U2? U1 is 2 on the right. U2? U2 is? Okay, minus 1 1 or 1 minus 1? Same thing. 1 minus 1 minus 1 1. So now, you have to, this is, see, because if you look at alpha 1 0 and alpha 2, they are really unknown so far. Okay? What is the formula of alpha 1 0 here? Inner product? X naught? V1 bar, yes. V1 bar divided by, here it is not that complex, so go to Korea go. V1 bar alpha 2 0 x 0 v2 bar divided by u2 bar v2 bar. Okay, what is x0 bar? Is it given for this problem? What is x0 bar? Is it given? x0 bar is given. 2 gram more per cc and 3 gram more per cc. 2 3 not 2 1. I don't know why you are saying 2 1. It is given 2 gram more cc and 3 gram more per cc, right? 2 and 2 3, right? Not 2 1. Am I correct? Yes or no? 2 3. Okay. So now we have, our job is to find out V1 V2. Otherwise you cannot do anything. So what is A transpose? matrix? Minus 1, 2, 1 minus 1. Correct? What are the B vectors now? Eigenvectors of this conjugate matrix or transpose matrix? Eigenvectors are same. You can verify. Eigenvectors have to be same, you verify. I don't expect you will get it again because same eigenvectors you get. There is a theorem you have seen. Eigenvectors are same. Eigenvectors are same. What are B1 and B2? B1 is how much? 1, yes, you are right. And B2 is? B2 is? If you generally you don't write in terms of fraction, so you choose alpha such that you get the round numbers. 1 minus 2. Doesn't matter. Minus 1, 2, 1 minus 2. Okay. Now the solution. We have now come to the final step. What is my equilibrium solution? At equilibrium, time tending to infinity. We have seen it in chemical kinetics. So, at x bar, t tending to infinity equals to alpha I0 e to the power lambda IT u bar alpha 1 0, right? I am not saying the second term. Why? Because lambda 2 is minus 3. If t tending to infinity, this term will be going to 0. Am I correct? So, lambda 2 is minus 3. So, that's what I am saying. For equilibrium problem, lambdas have to be either 0 or negative. If they are positive, what actually happens? This equilibrium cannot be happened. You know that. It will be done as a situation. So, eigenvalues are so interesting in chemical reaction engineering. Eigenvalues negative will make sure your system is going to equilibrium. So, for equilibrium problem, eigenvalues are the real deterministic factor and they have to be either negative or 0. And 0 eigenvalue corresponding solution will be giving the equilibrium solution. So, eigenvalues not only having the mathematical implications, but it is having the real impact on chemical reaction engineering. For equilibrium problem, lambdas or eigenvalues have to be negative or 0. If it is positive, it is not equilibrium problem, it is a sort of thermal runaway situation. So, the equilibrium problem, you cannot have eigenvalues positive. So, at equilibrium, you got only this solution, which is alpha 1 0, e to the power 0 is 1, right? Lambda is equal to 0, infinity is 1, and it is u 1 bar. What is alpha 1 0? Okay, let me calculate alpha 1 0 and give you the answer. 5 points, excellent. 553, you got it. 553 into 1, u1 bar is already obtained, which is 2 1, right? Which is 2 1. How much you got? Equilibrium solution now? 10 by 3 and 5 by 3. So your solution is, your equilibrium concentration is for x. So this is nothing but x1e and x2e. So it is 3.33 gram mole per cc and it is 1.66, I think. Let's check it out. Gram mole per cc. So you got the unique solution by the time dependent approach. Analyze them. So how you can see that how dxdt can be analyzed for a typical chemical reaction engineering problem where we are going to achieve the equilibrium concentrations. Any question? We are doing chemical reaction engineering, so you can appreciate here what we have learned and how mathematics play a role in here, right? Okay. So we'll go to the next problem. Problem number 2. A steel ball of volume 1000 cc, rho is 1.25 gram per cc and Cp 0.8 per gram per degree centigrade is at uniform temperature of 100 degrees centigrade. This is brought into an insulated vessel containing 5,000 cc of water at 20 degrees centigrade. Determine the steady state temperature of water and its still water in the spatial gradients in both the ball and the fluid. The heat transfer rate UA between the ball and the fluid is 1000 calorie per second per degree centigrade. Hint, use the subscript B for the ball and W for water and apply energy balance. So what I expect you to give me the equation and then we see how we apply A is equals to X or X equals to B.
Minus actually minus equals to no BC.
We just look at the unit in both the sides. You look at the unit in both the sides. We just see whether the unit is matching. So you should first write an equation of energy balance. Where unit is, so basically some of you will be writing GATE exam for getting job next year, right? And this is the very important question. Okay? So I am also teaching for GATE exam in this class. Because I am sure that 50% of you guys will be leaving. And we are giving a free GATE consultation. And these are the things, when you do the energy balance equation for this type of problem, if the unit is not balanced, you won't get the correct answer. So let's look at your unit is balanced and you are going to get the correct answer here. Yes, what is your equation? B is the ball and W is the water. Draw the geometry. This is steel ball. This is the typical gate exam problem. A steel ball of volume, this uniform temperature 100 degrees centigrade, and this is dropped into insulated vessel. This vessel is insulated. No heat loss here. Okay? This ball is dropped in the vessel. Okay? What is the equation? For the ball and the vessel, please look into the units in both the sides. When you write, definitely temperature change is dTV dt and dTW dt. Okay? Fill in the blanks. There is something here and something here. What are the somethings? What are the somethings? You look at the units and give the answer. Let's see who can crack a GATE score, very good GATE score. This will give some idea. And who can crack it, definitely you can go next year to GATE exam. You don't have to complete MPhil. You know that. You don't have to complete MPhil here. You can go for GATE exam and then get some public sector job. And I am working for that. How you can get public sector job. Okay. What is that? Left hand side. VEB, yes, you are going to right direction. What is VEB? Rho B, CBB, and then here minus 2A. Next here VW, Rho W, CPW, last UA, P minus. That's it. So using the relevant values, the given values, we got dTV dt equals to minus Tv minus Tw and dTW dt, which is 0.2 into Tv minus Tw. Am I correct? Check your values. Yes or no? Yes? Yes or no? Please check the values. Okay, go back and check the values. I am trying to verify it because it will take a long time and I have to proceed further. So if you do that, again the equilibrium problem, the solution is Tv equal to Tw. But what is the answer? We don't know. We don't know the answer. We know that, okay, water temperature and water temperature is the same. If the client asks what is the temperature, you cannot give the solution. But if you do dx dt equals to Ax, you can give the solution. Okay? How to get? So again, at equilibrium problem, this can be solved. So what is the A matrix then? So if you try to formulate dx dt equals to Ax, what is the A matrix? Minus 1? 1? 0.2 minus 1. Okay. And lambdas will be? Lambdas will be? Lambdas will be 0 is there, definitely we know that without 0 you cannot get the correct answer. Another eigenvalue you need. Otherwise you cannot get eigenvector.
Minus 1.2.
0 and minus 1.2. If you got plus 1.2, you get wrong answer. Okay? Because equilibrium, then equilibrium cannot be achieved. You know, physics is saying equilibrium will be achieved, right? It's quite obvious. If you put a cold ball to a hot water, both water temperature will be reduced and water temperature will be cold ball in hot water, water temperature will be reduced and hot temperature will be increased. That is physics is saying. Mathematics is saying that okay, eigenvalues will be negative for that. Mathematics is saying eigenvalues will be negative. And with mathematics you can get the right answer, which physics is actually negative. Okay? So what are the eigenvectors?
1, 1.
You got 1, 1, next one. Next one is next one is 1, 1, next one. Next one is how much? How much it is? Minus 5?
Minus 5.
Okay, so we can derive V1 bar. Now it is quite straightforward. We have done quite a lot of this. V1 and V2 bar, which is 1 minus 1. Okay, what's the initial condition? T0 bar, which is T0 bar is nothing but TB0 and TW0. What's the initial temperature of the ball? 100. Initial temperature of water? 200. Initial condition? 20, no problem. 20, yes. Then what is alpha 10? We need only alpha 0. We know that alpha 0 is not required because at t time to infinity, that term will go to 0. Alpha 0 is how much now? V1 bar I have given. You don't have to evaluate. I am giving V1 bar. Alpha 0 is how much? Pardon? 100 by 3. So steady state TB is SS, TW SS. How much it will be? How much it will be? Attention please. I'm just hearing some buzzing. This is not a fish market. If you don't know anything, you can sleep, no problem. I will not disturb you. How much? 100 by 3. 33.3, 30.3. So you can see that with this technique, we are getting the exact value also. So this technique is so far. How much is the product technique so far?
That's 2 minutes.
1 minute, 1 minute. 1 minute.
1 minute 30 seconds.
Okay, so next problem actually we can look at. Consider a series reaction. A is 2 second inverse and B to C is 3 second inverse. Okay, occurring in a CS state. We restrict the reactor operation to isothermal and the reaction to be fast forward. Okay, the feed to the reactor is pure A at a concentration of 1 gram mole per cc. Determine the evolution of concentration of A, B, and C in the CS state at the steady state. The residence time of the reactor is 4 second inverse. What I will do, I will give you the equation and you go home and solve the problem. Because we have solved enough problems, we have no idea how to do it. So you can see, again I am coming back to the chemical reaction engineering because this kind of technique has enormous application in reaction engineering. Okay, so I think I will stop because the time is up, right? And next I will see you on Monday. And thing is that next week Friday there is no class because I am going to give some other lectures on this on my mathematics. So to some other place, so I won't be here. So next week Wednesday we have a special class 5 to 6:30, 4:45 to 5:50, whatever.